first stage is new state, there are 5 states. Okay, after that runnable state, then running state, terminate state, blocked state. Okay, here suppose we have three user defined thread. So first of all we will create the object of this thread. Like suppose we have three object of new thread, name is t1, t2, t3. t1, t2 and t3. Okay, I have three object of three user defined thread. After execution of start method, it will transfer from new state to runnable state, like t1, t2 and t3. Okay, and they will transfer from after execution of start method, it will transfer from the new state to runnable state. Okay, and they will wait for the execution. Which one will get the process cycle of CPU that will load from runnable state to running state. Like suppose T2 will get the process cycle of CPU, so it will transfer from the runnable state to running state. Okay, and it will execute L a time slice. Actually CPU only one task can execute at a time, but we are trying to execute multiple program at a time. Okay, so suppose we have three program, P1, P2 and P3. Okay, and P1 have to need 3 seconds for execution, 5 seconds for execution and P3 for 2 seconds for execution. Suppose, okay, actually our CPU cannot execute multiple program at a time, so we use round robin scheduler. Actually our CPU perform using two types of scheduler. First, round robin, and second, priority base. Okay, in round robin it will provide the time slice, a very little time slice for all program, like 1 second for P1, 1 second for P2 and 1 second for P3. After completion of this cycle, again it will start automatically from P1 to P2, P3, like P1, then P2, then P3. Okay, P3 have completed, then again P1 for 1 second, P2 for 1 second, and P3 P1 have completed, then all time slice will provide with P2. So uh, CPU provide the JVR here actually JVM will in figure, and they will provide the very little time slice for all one by one all process, all program. Okay, so we will feel just like all program is executing simultaneously, but actually uh, one program will execute at a time. Okay, so here which thread will get the process cycle that will transfer from the runnable to running state. Okay, and execute its own time slice, and after completion of the time slice it will transfer from the running state to blocked state. Suppose uh, T2 will execute 1 second. After that, it will transfer from the blocked state. When it will transfer the blocked state, process cycle, any other process cycle, like suppose C3, T3 will get the process cycle. So it will transfer from the runnable state to running state, and then T2 again transfer from the blocked state to runnable state. Okay, and T3 will perform the execution within the time slice, and after completion of the time slice it will transfer from the running state to block state, and then again which one thread will get the process cycle, that will that will transfer from the runnable state to running state and start the execution, and after completion of time slice it will transfer from running state to blocked state, and this which thread is in blocked state, that will transfer from the blocked state to runnable state, and after completion of the process it will transfer from the running state to terminate state. Okay, so that is the whole process of the cycle. If you want to execute, you want to transfer your running thread from running state to directly to runnable state, for this purpose we use yield method. It will transfer our executing thread from directly from running state to runnable state. It will not transfer to blocked state. And then when it will get the process cycle, it will transfer from the runnable state to running state and start the execution. And after completing a time slice, it will transfer from running state to blocked state. And which one thread that is waiting in the runnable state, that will get the which one will get the process cycle, that will transfer from runnable state to running state. And after completion after their process, it will transfer from the running state to terminate state. Okay, but suppose T1, T2 or T3 any thread is executing, but it have need some input output. So it will transfer from the running state to, it have need suppose input output. Okay, it have need of input output, so it will transfer from the running state to block state. Okay, when it will get the input output values, when we will submit the input output value, then it will transfer blocked state to runnable state. Okay, suppose a thread is executing, but that thread have need of input output values, that will then it will transfer from the running state to blocked state. When it will get the input output value, then it will transfer from blocked state to runnable state. Okay, and again it will wait for the process cycle, then it will get the process cycle, then it will transfer from runnable state to running state and start the execution of remaining part. Okay, same as suppose we will use sleep method. Okay, so then again it will sleep method, then it will transfer from the running state to blocked state, and after timeout it will transfer from the blocked state to runnable state. If we are using suspend state, then it will transfer from the running state to blocked state, and after execution of resume method, it will transfer from the blocked state to runnable state. If we are using wait method, then it will transfer from the running state to runnable state, and after execution of notify or notify all, we can execute anyone, notify or notify all. If we will transfer, if a thread will transfer through the wait method from running state to blocked state, so after execution of notify method or notify all method, it will transfer from the blocked state to runnable state. So there are multiple reasons to transfer a thread, a running thread, transfer from the running state to blocked state. First, input output values had input output values, then it will transfer. After submission of input output value, it will transfer from the blocked state to runnable state. If we are using sleep method, so suppose we have declared 1 second, so after timeout, it will transfer from the blocked state to runnable state. If we use suspend method, then it will transfer from the running state to blocked state to, sorry, running state to blocked state, and after execution of resume method, it will transfer from blocked state to runnable state. Same as if we are using wait method, so after execution of notify or notify all, it will transfer from the blocked state to runnable state. Okay, suspend state, suspend method and wait method both are same, but currently we are using wait because uh, at the time of, if you are using suspend method, so say if a thread will transfer from the running state to blocked state, it will transfer with process cycle. Okay, so for this reason currently we use wait method. Okay, and if you want to transfer on the blocked state to runnable state, so for this purpose we use notify or notify all method. Okay, and after completion of the execution, our thread transfer from the running state to terminate state. So that is the whole life cycle of thread. Okay, so I think you understand this. Any doubt, any queries? You can see here, this is a, suppose, uh, thread 1, thread, suppose this is a, currently my ID is not responding. I'm waiting it. Here. Close all. Okay, so here you guys, this is the first thread, second thread, and third thread, and this is the example. Yes, you can see this. So here you can see this. Here we are creating the object of thread. So that is a new state. Here after execution of the start method, it will transfer from new state to runnable state, and when it will get the process cycle, then it will transfer from the runnable state to running state and start the execution. After completion of the time slice, it will transfer from the running state to blocked state, then blocked state to runnable state. And when it will get the process cycle for the execution, it will again transfer from the runnable state to running state and start the execution the of remaining part of the program. And after completion of the program, it will transfer from the running state to terminate state and complete the process. Okay, so these thread is executing within the a process. Okay, so now I'm going to create a example of multi-threading. Why we are using multi-threading? What is the meaning of this? Okay, and what is the benefit of this? So for this purpose, I'm going to create a example Java project. Now I'm going to create a first thread. Suppose thread name is 1. And suppose we want to perform to print a series of prime number. Okay, so I'm going to create a extend thread. Then public void run method, and suppose we want to write a program for print the series of prime number. Okay, so for this purpose, for int I is equal to 1, I less or equal than 20, and I plus plus. Suppose we want to print the all prime number from 1 to 20. Okay, so for this purpose, here I'm going to declare here count a variable, and again if int j is equal to 1, j less or equal than I, j plus plus, okay, and check it if I mod j is equal to 0, then count plus plus, and after termination of loop, second loop, like here we can check it, count is equal to 2, plus I. Okay, if count is equal to 2, then it will print. Okay, so there is a, suppose to the first thread I am trying to print the series of prime number. Okay, second I am going to create second thread. Extend thread, okay. Suppose you want to print the series of Armstrong number. For this purpose, I declare here I'm going to start from 100. I less are equal than 500 I plus plus okay. Now to 0 and use while, and here I save temp is equal to I, and here temp is greater than 0. Currently I am trying to write the program for Armstrong, so here int is equal to temp mod 10 and sum is equal to sum plus rem into rem and temp is equal to temp upon 10, and after that here, after completion of the loop, we will check it if I is equal to sum, then print on the strong number plus I, okay, same as we can get. So through this I am trying to print the series of Armstrong number, and now I am going to create another thing. Okay, no problem, we can create only two no, okay, one, only two thread. Okay, and now I'm going to create main thread, so new class, and here example, add public SQL main, click on finish, and now we can create the object of thread. So one t1 is equal to new one, and same as we can create the object of 2 is equal to new, okay, then t1 dot start and t2 dot start. Okay, save this file, and now we can execute it. And here it goes in the prime number and Armstrong number. If you want to show this simultaneously, so we can use here at the time of printing this, we can use here try catch. For this purpose I am going to use sleep method, and I am going to specify 1 second. Okay, so this is a, it's returning the exception, so here I am going to use try catch. Okay, same as I'm going to create second thread, and here declare thread dot sleep for 1 second, it's also throwing this exception, so we can use try catch, save this file and try again. I'm going to execute it. Now you can see here our thread will execute simultaneously. You can see this prime number, abstract prime number and abstract number. Okay. So same as we can create multiple thread. Like here, first thread I'm using to print list of prime number. Second, using for print the Armstrong number. Okay, same as you can. So actually I want to explain this. Through the one thread we can perform a one task or one program. Through the another thread we can execute another program. We can get another thread and we can perform another program. Okay, so actually we can perform multiple tasks simultaneously. Okay, through the multi-threading. Okay, but suppose you want to execute, you want to perform one thread. Suppose you want to complete the execution of one thread, after that you want to execute another thread. So you can do this through the join method. So for this purpose we can use the t1.join. Must be remember this. We can use join after the execution of start method. We cannot use join method before the start method. Must be remember this. Okay, it's also throwing the exception. So we can add the try catch. Okay, so here we can add the all things within okay, so here you can see this. We are using join method after the execution of thread 1. Okay, now you can see this. So with the help of join method, if you use join method with t1, so first of all it will complete the execution of first thread. After that thread 2 will be executed. Okay, same as suppose here we want to write the program for main method. So for through the main method I am trying to print int I is equal to 2, I less or equal than 20 and I plus equal to 2. Okay, and here I am trying to print even number plus I, and we also use sleep method and specify here 1 second. Okay, now so now you can see here so first t1 will complete the execution of first thread. After that you can see this event number or Armstrong number. Okay, it means second thread is executed after second and main method. But suppose you want to also want to complete the execution of second thread, so again you can use join. Then you can see this, it will execute. First of all it will execute t1. After that second thread will be executed. After that main method will execute. Main thread will be executed. Okay, you can see this prime number, Armstrong number and event number. But we used multi-threading for execution of simultaneously. Okay, but if you have need you want to complete execution of any thread, so then you can use join. Otherwise, this is not a actual use of multi-threading. Multi-threading means we can execute more than one program, multiple program simultaneously. Okay, second thing, if suppose you want to execute the main thread at the end of the execution of all thread. Okay, like suppose here I have declared join at the end of the start method. What is the result of this? You can see this. First of all, thread 1 and thread 2 will be executed, and at the end of this and executing simultaneously. Okay, but end of the execution of this thread, main method will be execute. You can see this. So if you want to execute main method at the end of the execution, you can use join method like this. Okay, now if you want to specify the priority of thread, it is also possible. So for priority here, you can say this. If you want to set the priority, but actually, if we did not declare the priority, JVM automatically declare the priority of all thread. Okay, we have not need to declare the priority of thread. JVM by default it will declare the priority of thread. Okay, first thing. But suppose we want to declare the priority of thread, so we can do this. We have set priority. To the set priority, we can set the priority. Suppose thread is T1, so T1 dot set priority, and here we can specify the priority. Same as if you want to get the priority, if you want to know what is the priority of my thread, so you can use get priority. Okay, but here what is the meaning of set priority? Here we are not specify anything. So for this purpose, Java provide us a constant, that is a thread dot max priority. Max priority. Okay, thread dot norm priority. These are the constant, and thread dot min priority. Okay, and max priority is equal to 10, norm priority is equal to 5, and min priority is equal to 1. Okay, so if you want to set the priority of any thread, so for this purpose we can declare, like suppose max priority, we want to set the max priority, so here we use T1 dot set priority thread dot max priority. Okay, same as if you want to declare non priority, so we use thread dot non priority. If we want to set as min priority, so we will use thread dot min priority. Okay, and we can also use here like here we can, suppose we want to set the max priority, so at the place of thread dot max priority we can also declare here 10, because max priority is equal to 10, so we can also directly declare the values. For non priority we can declare 5, for the min priority we can declare 1. Okay, so suppose we want to check what is the current priority of this thread. Okay, so I'm going to stop the execution of this. Okay, make it. What happened? Okay, try catch. I have need the of this. No, showing error. So we can make it, and here we can also. Okay. Now, suppose we want to know the what is the priority of T1 and T2. For this purpose, first thread priority plus T1 dot get priority. Okay. Same as suppose we want to print priority of second thread priority plus T2 dot get priority. Okay, and now we can check it. Okay, 5 and 5. By default, JVM set priority of all thread as a not priority. Okay, suppose we want to change it, so we can use here T1 dot set T1 dot set priority, and here I have declared 10 R1. Okay, min priority. Okay, and T2 dot set priority as a 10. Okay, after that I am going to check the current priority. Okay, now I'm going to execute it. Okay, 5 5. The main priority is 1 and second priority is a 10. Okay, so we can check it, but we can set this. We can set the priority of anything, but actually this is depend on JVM. It will work on priority base. Actually, in multi-threading there are two types of scheduler. First is round robin and second is priority base. Okay, but which JVM will use which scheduler, it's depend on only depends on JVM. We cannot decide which scheduler will be execute, priority base or round robin. Okay, if priority base we use, then JVM will use this priority. Check the priority of thread, and according to this, JVM will be execute that thread. But it fully depend on JVM. JVM will decide it. It will execute on the basis of priority base or round robin. Mostly execute your thread on the basis of round robin. Okay, so we can we cannot see the more effect of that priority in the execution of thread. So we can only see the effect, only very little bit effect we can see of the set priority. Okay, so now I'm going to check it. to execute it. Okay, now priority set is 1 and 2. Here the second priority have high priority, so Armstrong number is executed. After that prime number execute, then Armstrong number, then prime number, then Armstrong number, then prime number. And after execution of Armstrong number, then prime number and even number, because here I used join also. So I'm going to, okay, so currently we have three thread. First is first one thread, second two thread, and example. So now I'm going to save this and try to execute it. And you can see this Armstrong number, event number, prime number. Armstrong number have high priority, but you can see this first execution of the Armstrong number, then event number, this is the main number, then prime number, then Armstrong number, then event, then prime. Okay, so we can see the very little bit effect of the priority base. Otherwise, mainly it execute on the round robin. Okay, so that is the use of multi-threading. Through the multi-threading, we can execute more than one program at a time. Okay, the next topic. Any doubt, any queries? Okay. Now I'm going to start the next topic. That is a file input output. What is the file input output? So I'm going to only give in the introduction of file input output topic. In next session we will try to create the examples of file input output. Currently I'm going to only the introduction of file input output. What is the file input output? Actually, if you want to perform any operation, like suppose you want to insert the value, if you want to, suppose here this is also a notepad is also example of file input output. Actually, suppose if we want to save any data or information permanently in our system, so we have only two options. First is file system, and second is a database. Okay, so we have only two options to store our data permanently in our system. First is a file system, second is a database. In file system, it's a notepad, wordpad, any editor. These are the examples of file system. There is no rules and regulation. We can type anything anywhere. Like here you can see this. You can type anything and we can store it permanently in our system. This is the file system. Okay, we can here we can click on new, and we can create a new file. To the open, we can display the content of file. To the save, you can save the file permanently in our system. To the save as, we can create a copy of already exist file. Okay, so we can perform this operation in file system. So here this is not a miracle. If you click on new, then we can create a new file. If you click on open, so we can display the content of already exist file. If you click on save, so we can save the data in the database in the system. And if you click on save as, so we can create a duplicate file of already exist file. Okay, so it is not a miracle. Actually, when we click on this option, so a program will execute in the background. So actually we will create the program of that program through the file system. So in file system, we will try to create the program of new file, create the program of open, create the program of save, create the program of save as. So in file system, we will create the program files, program of these options. Okay, so here we are going to use file system. In file system, Java provide us a concept named is file input output. So database we will use in JDBC, but currently we are going to work on file system. For file system, Java provides a concept named is file input output. Okay, so what is the new in Java? Because before the Java we have many languages like C and C++. So what is the new in Java? So actually in C and C plus C and C also we can perform the file input output. The concept name is file management. So suppose we want to work on C language. Okay, in C language the data directly transfer from program to C, program to input output device. Input output device. Okay, but in Java first of all it will not transfer from Java program to direct to input output device. Input output device. Okay, no, actually in Java first of all transfer our data in a buffer. First of all it will save in a buffer. Okay, after that the data of buffer transfer from buffer to input output device. Okay, in C language it directly transfer from the program to input output device, but in Java first of all it transfer in buffer. After that it will transfer from buffer to input output device. So you can say what are the difference between both and what is the benefit of this. So actually suppose you are working in your office. Suppose you have a office. Okay, and you want to change the location of your office. Okay, so suppose this is a source location, there this is your current location of your office, and this is a destination. You want to transfer from source to destination. Okay, and you have some item like laptop, printer, AC, table, chair, etc. in your office. Okay, and you want to transfer this item from your source location to new location, destination location. So you have two ways. First, you can pick one item and transfer from source to destination. Pick second item and transfer from source to destination. Pick third item, transfer from source to destination. One by one, you can pick the item and transfer from source to destination. Okay, that is the way of Java. But suppose what is the new in Java? This is the way of C language. Okay, we can transfer the item from one source to destination one by one. But in Java, we will hire a truck and load the all item in this truck. and then transfer that truck from source to destination. That is the way of Java. We had a truck and load the all data in truck, and that truck move from source to destination, and in one attempt we can transfer the all data from source to destination. So it is faster than C language. Okay, in C language data transfer one by one, directly transfer to source to the input output device, but in Java it transfer, first of all transfer in buffer, after that it will transfer from buffer to input output device, and this buffer is called stream, and stream is a collection of bytes. Okay, so actually this is buffer is called stream, and stream is a collection of bytes. Okay, and Java provide us two type of stream. First is type of stream. First, so actually Java work on the basis of stream, and stream is a collection of bytes, and there are two types of stream. First is a byte stream, and second is a character stream. Okay, there are two types of stream, byte stream and character stream. For byte stream, Java provides two abstract class. First is input stream, and second is output stream. Same as for character stream, Java provides us two abstract class, name is reader and writer. Okay, through the input stream we can read the data from the keyboard, from the file. Okay, through the output device, output stream, we can write the data on the console or on the file, in the file. Okay, same as reader, through the reader abstract class we can read the data from the keyboard or file, and writer is used to write the data in file or write the data on console. Okay, but these are the abstract class, so we cannot work on abstract. We have need of implemented class, extra subclasses. Okay, so we will discuss about this in next session. What are the list of subclasses of these abstract class, and how to perform the new program of new file, open file, copy file. We can how to perform the different operation on the file. Okay.